Hey guys, welcome back. So today I brought home this 5,000 watt Husky generator. It is powered by a 9 horse Briggs & Stratton engine, and this doesn't make power. The seller listed it at $285, which is a lot of money for something that doesn't do what it's supposed to do. So, I offered him $100. He turned me down, but a day later he countered at 170 and asked if I was interested, which obviously I was, because here it is. Now, in the description, he did state that it needs a new circuit breaker, which costs $70, and most likely that is the cause of the problem. So, maybe it is, maybe it isn't. Unfortunately, he took the circuit breaker out and it didn't come with the generator. So there's no way to test that, but I do have extra circuit breakers. Worst case, I do have also an extra power head. So one way or another, this will make power again. But before just throwing another circuit breaker in there and starting it up, I'm going to pull the end cover off the generator head. I want to look at it visually, make sure it looks okay, and I'm going to check each coil and make sure that each one is healthy. And if that all checks out, we'll get that replaced, we'll bring it outside and see what it can do. So let me get you set up a little bit better and get going on this thing. So I got the AVR out of the way just to get a better look at the stator. And the windings seem to be in pretty good shape. I'm not seeing any broken ropes, no obvious problems. So we're off to a good start. I think I'll get the multimeter out. We'll test each of the coils and see if things keep looking good. So on this generator, you can test the ohms directly down here, but there's also this quick disconnect plug, which I do like to use. I do use this quite a bit. And the way it's wired is that leg 1 is diagonal from each other and leg 2 diagonal the other way. So we'll just check one of the legs right now. And this should be around 0.4 ohms. And it is. And now the other leg. We get the same. And those readings are consistent, which is good. So now I'm just going to test this to ground, make sure there's no connection. And there's not. We'll try the other leg to ground. No connection. So it seems to be good. You can also check the other main winding, make sure there's no cross connect. And there's not. So the main windings appear to be in good health. Next, we should check these here. We have 2 blue wires, and those supply the power to the AVR. Those are the excitation windings. And the white and green wires are the sense windings. And generally, they are connected into the main winding. So if the main winding is good, most likely the sense is as well. All right, we'll start with the blue wires, which should be about 1.5 ohms. We're at 1.6, 1.7. This meter has an internal resistance of 0.1, so That puts us at 1.5 ohms, which is good. We'll also check this to ground, and there's no connection. We'll check it to the sense winding, no connection, and check it to the main winding. No connection. So the excitation winding seems to be good. And the sense winding should be about the same as the stator, which is 0.4 ohms in this case. We're at 0.2, 0.3. That's good. Let's just check it to the excitation winding. No connection. And we'll check it to the main windings. And there is a connection, but that's okay. It is the sense winding, and that is usually part of the main winding. So things look pretty good. I guess the last thing to check is the rotor health, and I'm going to do that through the brushes. This rotor should be 70 ohms or less. It's probably going to be higher actually going through the brushes, which wouldn't surprise me. But as long as we're, around 100 or less, I would consider that good when going through the brushes. Yeah, that's way too high. Yeah, that number's too high. That's 0.3 thousand ohms. That's much too high. So I'm going to get the brushes off. We'll do the test again. Yeah, the brushes themselves look to be in pretty good condition. Yeah, we're around 53 ohms. So those slip rings must be pretty dirty. It was hard to get a good reading. Yeah, it's pretty hard to show you, but that's kind of the best shot I can get of the slip rings. They don't look awful, but it's enough to make the readings go pretty high. Probably the easiest way to clean the slip rings is using a piece of Scotch-Brite. The way I do it is I just hold it on a slip ring, and while doing that, I rotate the engine using the rotor bolt. Now, needless to say, use precaution because you are turning the engine over. You don't want it to start, so I always make sure the switch is set in the off position. I also remove the spark plug, not only to prevent it from starting, but now there's no compression, and it's much easier to do this. So you're not going to be able to see too much. My hand's going to be in the way, but that is the general procedure. I think the one thing you want to be careful of is that the wires from the rotor connect to the slip ring right next to the slip ring. So you want to be very careful not to knock into those wires, or you're going to make a big problem for yourself. So that there's the end result. They look much better, and that didn't take long at all to do. So let's get the brushes back on and take another reading. Yeah, much better. We're at 54 ohms. That's perfect. We'll just check it to ground to make sure there's no connection. And there's not. So, from what I can tell, at least at the low voltage tests with the multimeter, this power head is good. And when reconnecting the brushes, make sure the red wire, which is the positive, goes on the left brush. Okay, that's it for now. I'm going to leave the end cover off until we know there's nothing else going on in here. Now, as far as this outlet goes, I could replace the circuit breaker, but I do have another whole box here I can just install, complete with the circuit breaker. So that's probably the easiest thing to do. There's only 4 nuts in the back here holding this box in place. So I'll get those out, swap a new one in, and we should be good to go. Well, I wasn't going to film this part of it, but I do drain the fuel from everything I get, regardless of the run condition of the machine. And supposedly this is a good running engine. Haven't actually started it yet, but what I just drained out of the tank tells me otherwise. I pulled the fuel line off the carb. The fuel inlet actually has rust on it, and the fuel itself, it's pretty expired. I can't even see the bottom of the cup. So yeah, we'll get the rest of this out. Potentially, the carb might need to be cleaned as well. Okay, let's give this thing a try. I've got the test tank hooked up, mostly because I don't want to fill that tank with fuel now that it's empty. Let's see if this thing starts and makes power. Okay, well, I thought I was going to get away with not cleaning the carb, but as you can see, it's not starting. So most likely it is the carb. We'll get it inside again and pull it off and clean it up. Before pulling the carburetor off, I am just going to spray a bit of starting fluid in there. I want to make sure we don't have a spark issue. Yeah, that was a bit unexpected, but it started right up and kept going until it ran out of fuel because I don't have the test tank hooked up anymore. Let's get this back outside. We'll try it again. Okay, let's try this again. Yeah, we get nothing, just like last time. So there is something going on inside that carb. It has to come off. So I was only able to crack one of these loose with the impact. These are JIS screws. I tried a JIS screwdriver, wasn't having it, and the impact isn't either. So vice grips work well. You know, this is already getting chewed up, so don't want to make it any worse. We'll just crack it free with the vice grips and then get it the rest of the way out. There we go. It doesn't look too bad in here. That's the main jet. Can usually poke that out easy enough. The main jet's not clogged. So, yeah, I mean, overall, this doesn't look too bad. Potentially there was water down there. I think a lot of it dripped out before I could really catch it in the cup. And, you know, the top part of the carb is pretty dirty. I do see some signs of something right there. And yeah, it doesn't take much. It could just be a little clogged passage. There's also some passages right here. These two tubes pick up fuel, but they don't look clogged either. So yeah, I'm suspecting a quick clean and the ultrasonic should bring this right back. All right, well, I'm going to leave this seal alone. I don't like putting it through the ultrasonic. The solution I use doesn't cause them to expand like carburetor cleaner, but it at times can shrink them. And yeah, this needs to be a perfect fit, but it's stuck in there so well, I don't think I need to worry about it. It came out pretty well. So this should run. I didn't really find any smoking gun as far as why it wouldn't. I think the best I could come up with was the debris that was up here or potentially some water in the system. So let's get this back together and see if it'll run now on its own. Okay, let's try this again. It's a little bit slow, and the voltage is also a bit low. Okay, well that's more like it. Started first pull, turned the choke off right away, and the engine sounded good. The engine speed was also decent. It was at 61, about 61 hertz, but the voltage is low. It was just over 113 volts, so that has to be bumped up. You know, under a 3,000 watt load, the engine did pretty well. It was about 58.5 hertz, so it's a drop of 2.5 hertz, which isn't too bad. I mean, this is not a 10-horse engine like the Storm Responder. This is actually a 9-horse engine. This generator is only rated at 5,000 watts, so it held pretty well. I think I'm just going to pop that AVR off, adjust the potentiometer a bit, and see if we can't get that voltage closer to 120 volts, if not a little bit over. And that is the potentiometer right there in the adjustment screw. Usually it's clockwise to bring the voltage up, so that's what I'm going to try first. Now, the sensitivity varies among these. A lot of times, one full turn will get about 2 volts. Sometimes it'll get 20 volts. So don't go crazy on it. Maybe start with the turn, see where the voltage goes, and then fine-tune it from there. That came up 2 volts. Yeah, so one turn brought it from 113 to 115. So we need at least 2.5 more turns. Beautiful. Okay, perfect. We're now at 120.7 volts. So I'm going to get this back inside, get the oil changed while it's hot, and then we'll finish putting this thing back together. And you can see this is what came out. It's actually very clean, probably one of the cleanest I've seen. But, you know, I don't know what weight oil that was, and it's the middle of the winter, so potentially that's a 30 weight. And around here anyway, 1030 is much safer. So that's what I put in, 1030 synthetic. All right, I think you missed it, but you didn't miss much. All I did was get a zip tie around here and attach it to this bolt. The zip ties I use have this through hole right here, and that is for applications like this where you need a bolt to hold it in place. All right, well, that's pretty much it. I got the fuel line reconnected, and there's really nothing else to do on this other than maybe clean it up a bit more. So, got pretty lucky on this one. It was just the circuit breaker, and, for a minute there, I thought I was going to get away with not cleaning the carb, but seems like I always have to clean the carb, and this one was no different. But now it runs well, makes power, and yeah, that's pretty much it. So, hope this video helps someone. Thanks for watching.